For this video, I'm going to go over using our three similarity theorems. We've already talked about angle-angle similarity in the previous lesson, but I'm going to add two more in this one, side-side-side similarity for these triangles, as well as side-angle-side similarity. All right, so I'll summarize those real quick. So we have side-side-side similarity. All right, and so this is if the corresponding sides of two triangles are proportional, then the triangles are similar. Okay, and the other new one that we're going to use is side-angle-side similarity, and this is if the lengths of two pairs of corresponding sides of two triangles are proportional, and the angle the sides form are congruent, then the triangles are similar. All right, so we'll use those in this video, looking at side-side-side similarity, side-angle-side similarity, and also bringing in the one from our last lesson on angle-angle similarity. Okay, so you're going to see there's a lot of questions on this video. I'm not going to do all of them because the video would be too long, but please check Canvas for key for the ones that you did not get to see in the video. All right, so I'm going to start with number one. It says for each problem, circle the triangles that are similar to the original triangle. State the postulate or theorem that justifies your conclusion. All right, so in this first one, we have side lengths 2, 4, and 5. So it looks like based on what they've given me, I'm trying to use side-side-side similarity. So if I can find a triangle that has the same ratio or proportion for each of these corresponding sides, then that would be the one that is similar. All right, so if I look at this first one in letter A, I'm looking at 2, let me do some highlighting here, 2 to 4, 4 to 8, and 5 to 10. It looks like for each of those, I'm multiplying by 2 to get them. So actually, that was pretty quick. This one is our answer by side-side-side similarity. If you look at B, C, and D, you can see in this one, they're multiplying 2 times 2 to get to 4, but 4 times 2 does not equal 6. In this one, they're multiplying by 3. 2 times 3 is 6, and actually 4 times 3 is 12, but 5 times 3 does not give us 10. And then this one, they're dividing. 2 divided by 2 would be 1. 4 divided by 2, though, is not 3, and 5 divided by 2 is not 2. Or I guess you could be subtracting as well. But that's not going to work. It has to be a scale factor, which is going to be multiplying or dividing. Okay, so that was number one. I'm going to skip 2 and 3, so take a look at the key on Canvas for those. I'm going to go down to number 4. Same thing that we did in the first one. All right, can I figure out the triangle that's similar based on one of our three similarity theorems? Okay, so when I look at this, I see one of them has this here with the letter C is trying to go with the sides, but actually what we can do is we can actually say for this one that letter B is going to be our answer, and here's why. You'll notice this is 90 degrees. All right, so because that is 90 degrees, this 62 plus this other angle has to be 90, so 62 plus that other angle is 90 degrees. All right, so that's going to be 28 degrees as well. And if you look at letter B, we have the 90 degree angle and the 28 degree angle, which corresponds with this 90 degree angle and that 28 degree angle. And so that would actually prove that this one is similar by angle-angle similarity. All right, now this one doesn't have that angle that we need, and same with this one over here. Okay, so we're going to go with B in number 4. All right. Moving on to the next ones. So number 5, determine if the triangles are similar. If so, write a similarity statement and provide a reason to justify your conclusion. So that would be like the angle similarity, side similarity, or side angle side similarity. And if not, then we're going to write not similar. Okay, so in this first one, I'm going to do number 5. Based on these angle measures, I can take each of these, since they gave me 2 angles in each triangle, and find the third one. So 80 and 60 is 140. So this is 40 degrees. 60 and 40 is 100 degrees. So this is 80 degrees. And it looks like I'm going to be able to say they are similar. And you can choose which 2 you want to use. I'll choose the 60 and the 80. All right, and that's because of angle similarity. All right, so if we're going to go with KRE for the beginning of the similarity statement, I need to match up those angles with the next triangle, which would be SMT. All right, so that's that one there. I'm going to skip 6. Check out the key for that one. Here's 7. We're trying to do triangle FEG. All right, and based on this, I'm looking at my angles here, and I do have this vertical angle, and if I can see that the side lengths that make that angle in both these triangles are proportional, then we can use side angle side similarity. So let's see if that works. So I'm going to do 20 over 12, find out what that is, and then I'm going to do 35 over 22. And if those are the same, then I'll be able to say these are similar triangles. All right, so 20 over 12, I can do 20 over 12. And then the other one is 35 over 22, which gives us, oh, that's not 22, try again. Sorry about that. 1.59 as opposed to 1.6 repeating. So this is 1.6 repeating, and this is 1.59. Those are not the same thing. All right, so because those ratios don't end up being the same thing, we are not able to say these are similar, so not similar. But I was trying to do side angle side similarity, okay? Okay, let's keep going. I'm gonna do number 9. Number 9 says, find the missing measures of the angles and the sides of each triangle given triangle ABC is similar to triangle GHG. So since they're saying it's similar, right? They're telling me they're similar. I know that their angles have to be congruent. The corresponding angles are congruent. So I look here, angle B is 75 degrees. That matches up with angle H. So this angle H is 75 degrees. So I know one there. Okay. Then based on the fact that they gave me angle J is 35 degrees, that matches with angle C, which is 35 degrees. So angle C is 35 degrees. And then if I take those two and add them together, 75 and 35 is going to be 110. Subtract that from 180 and you get 70 degrees for the other ones. So angles A and angles G are both 70 degrees. All right. So now since we are told they are similar, I'm going to go ahead and based on what they gave me, because I can't find everything here, I have BA, which matches up with GH. And then the other one they gave me is JH, which matches up with BC. So I can find this side length with a proportion. So I'm going to set up 6 over 9 equals X over 18. All right, I'm going to reduce the 6 9s before I do the cross products, but you don't have to. 6 9s divided by, let's see, divided both by 3, I get 2/3 equals X over 18. Cross multiply, you get 3X equals 36, so X equals 12. So this side length there is 12 units. All right, and that's all I can find for these triangles. Okay, let's go ahead and I'll do number 10. Okay, number 10. A poster measures 10 inches in width and by 14 inches tall. So I'm going to do a poster is 10 inches in width and 14 inches tall. Okay, if we enlarge it to have a width, so I'm going to make this bigger, obviously not to scale, make it bigger. We enlarge it to have a width of 5 feet. 5 feet is 60 inches, so 60 inches. How tall will the poster be? Okay, so I'm going to set up my proportion here. So 10 inches over 60 inches equals 14 inches over, I don't know. All right, I can go ahead and reduce the 10 over 60 to be 1/6. Cross multiply, and you get our unknown is 14 times 6. Let's see, 28. Let's see, 14 times 42. I think it's got to be 84 inches. I can confirm real quick, but I'm pretty sure it's 80. 14 times 6. 84. We were correct. Excellent. All right, so 84 inches for the new the height of the new poster. Okay, let's skip. I'm going to skip 11, skip 12. Let's do 13, and then I'll do 15, and then we'll be finished. Okay, 13. Are the following figures similar? If so, explain why and write the appropriate similarity statement. If not, then explain why as well. Okay, so when I look here, I see that we have DE and GF are parallel. So using our understanding from the first semester that this transversal EG, I could say that this angle and this angle are going to be congruent based on alternate interior angles are congruent. And then when I look at this angle H, you can see that that is a vertical angle. So by angle-angle similarity, so using angle-angle similarity, I can write a similarity statement for these two triangles. So I'm going to write DEH is similar, try that symbol again, is similar, there we go, to, all right, so the E's got to match it with the G, so I say F, and then GH. All right, so that's 13. All right, last one, 15. Is triangle DOG similar to triangle CAT? Explain why or why not. Well, they gave me 3 side lengths, so I'm going to try to use side similarity. All right, so if all these ratios end up being the same, then I know that they will be similar triangles. So here we go. So I'm going to do DO with CA, which is 10/14. See what that one is. Then I'm going to do OG with AT, which is 12. See what that is. And last but not least, I'm going to do DG with CT and see what that is. Okay, so this reduces to 5/7. This is 3/4. And let's see, I can multiply that by 2 and get 15/20. Divide all that by 5 and you get 3/4. So those match up, but unfortunately 5/7 is not the same as 3/4. So you do need all 3 of them to be the same proportion or ratio. So since not all 3 of them were, these are not similar triangles. Close, but they're not. Okay? All right, guys, take a look at the key for the ones that I skipped, and then make sure to attend office hours if you have any questions. Good luck.